In this section, we're going to deal with exponential growth and decay. And for both situations, exponential growth and exponential decay, we have a similar formula. The formula is y equal a sub 0 e to the kt. A sub 0 will always represent the initial amount we start with, whether it's a substance or whether it's a population of something. Our t will always represent time. And our k will be some constant. Now, k will be positive if we're talking about a growth situation, and it will be negative if we're talking about decay. And then e is that same special number we've been talking about, 2.718. All right, so let's look at an exponential growth problem first. A biologist recorded a count of 360 bacteria present in a culture. After 20 minutes, 1,000 bacteria were present. Rounding to 6 significant digits, we want to write an exponential equation representing the situation. After we've written our equation, we are, to the nearest minute, going to determine how long it took for the population to double. All right, so let's not even think about the second question. Let's first write an exponential equation that represents this situation. So, first, let's write down y equals a sub 0 e to the kt. And now let's fill in. The initial amount of bacteria we have is 360. So we want to put 360 in for a sub 0. So that's our first thing. And apparently I am still in the exponent. Let me fix that. So we're going to put y equals 360 e to the kt. All right, now we're going to use the second piece of information. We have a point. In 20 minutes, there are 1,000 bacteria. So let's fill in. This is t, and this is our y. All right, so, oops, let me go back down here. So I'm going to put the 1,000 for y, and then I'm going to put the 20 for t. And we've got to solve this equation. Now let's notice this is an exponential equation, so let's take it through our steps of solving an exponential equation. Recall, the first thing we want to do is get the exponent and its base by itself. So here's the exponent and its base right there. E is the base, 20k is the exponent. We need that by itself before we can do anything else. So let's divide out the 360 that's over there with our exponent and our base. Over here, the 360 will cancel out, but we've got 1,000 divided by 360. That is 2.777 with many sevens. Now, since it says to take things to 6 significant digits, I'm going to take it to about 8 to begin with. 1, 2, 3, 4, 5, 6, 7, 8. And we will round off at 6 significant digits when we're done. So now we have E, and I'm going to rewrite it as 20 times K instead of K times 20, just because it looks more natural. All right, now recall, the second thing we do in solving an exponential equation, now that we have the base and the exponent by itself, is we apply the natural log on both sides. So we've got the natural log in front of this thing here. And we have the natural log in front of the e to the 20k. All right. Well, on the left, we can put natural log of 2.77777 into our calculator. It gives me 1.02165 124. Again, I'm going to take it about 8 digits, and then we will round to 6 significant digits when we're done. Remember that when the natural log and e are put together, they cancel one another out. So we just get 20k. And then let's finish solving for k. Let's divide out the 20. And we will get k is whatever this is, and I will go ahead and round this to 6 decimal places. And that will be 0.051083. Now that I know what K is, I'm going to go back to the very first equation that I set up right here, and I'm going to put K in. So I've got Y equals 360 e to the 0.051083 and then I still have the t. And now I'm going to answer my question. My question says, to the nearest minute, how long does it take for the population to double? All right, so we had 360 to begin with. Double that is 720. So I'm going to put 720 over on the left, and I'm now going to solve this equation to find the answer to my question. So again, we're solving a second exponential equation. So first thing I need to do is divide out my 360 and get the exponent and its base by itself. When I do that, 720 divided by 360 is 2. Next step in solving an exponential equation, let's take the natural log on both sides. On the left side, if we put the natural log of 2 into our calculator, that is 0.69314,718. On the right side, natural log and e cancel each other out, so I just get 0.051083t. And then let's finish solving for t. Let's divide out 0.051083 on both sides. And then I'll round that to 6 decimal places when I'm done, because that's what it told me it wanted the answers to. So t is 13.569038. So in a little over 13.5 minutes, I will have doubled the population of 360 bacteria to 720. And let's see that that makes sense, because it took 20 minutes for the bacteria to get to 1,000 bacteria. So certainly this should be less to get to 720 bacteria. 13.5 minutes is somewhere in between 0 and 20 minutes. So that makes sense.